In this lesson, we will define trigonometric functions sine theta and cos theta, and all other trigonometric functions which are derived from the definitions of sine and cos. We will also discuss the domain and range of these functions. Let's get started with simple definition of sine and cos. For this purpose, let us consider a point Pxy. Let Pxy be a point on the unit circle. Be a point on the unit circle. Unit circle means that the radius of the circle is equal to 1. So if this is a point P with coordinates xy, then the height of P above x-axis is y. If M is base of perpendicular from P on x-axis and O is the origin, then x is equal to OM and PM is equal to y. Now from the definition of sine and cos, now for triangle OPM, which is of course a right angle triangle, sine theta is equal to PM over OP, PM over OP, and cos theta is equal to adjacent over hypotenuse, means OM over OP. Well, basically we mean the length of OM, PM and OP. As PM is equal to y, this means y is equal to OP into sine theta. And similarly, OM, which is equal to x, is equal to OP into cos theta. Now, because this is a unit circle, so OP being the radius of unit circle, OP being, since OP is equal to 1, radius of unit circle. So that's why x is equal to cos theta. This gives us x equal to cos theta and y equal to sine theta. Since x, y are coordinates of the unit circle, therefore, since x, y are coordinates of the point on unit circle, and for every theta belonging to R, there is one and only one point, such that for every theta belonging to R, there is one and only one. There is one and only one, means unique. For every theta belonging to R, there is one and only one point P with coordinates cos theta and sine theta, because now instead of x, y, cos theta and sine theta are coordinates of the point on the unit circle. So x equal to cos theta and y equal to sine theta are functions of the variable theta, because this is exactly what is requirement of any relation to be a function. Like if x equal to cos theta is defined as a function, the requirement is that for every theta belonging to the domain, there must be a unique x belonging to range. And so is the condition for y is equal to sine theta. And sine theta and cos theta fulfill all those conditions. So these are the functions, and now we want to find out the domain and range. Now domain and range of sine theta and cos theta and cos theta. Now since x and y are points on the unit circle, since x and y are coordinates of the point on unit circle, obviously x and y cannot have any coordinates, like they cannot leave the unit circle. So the relation that the distance from the center to the coordinates xy must be always equal to 1. That must be maintained always. This means, and x can horizontally move between point, if let's say that here is the point 1 0 and here is the point 0 1, here is the point minus 1 0 and here is the point 0 minus 1 on the circle. Let's call this A, B, C and D. A can only variate between A and C. So x can only vary between C and A. This means, and y between points B and D. Y between B and D. This means that minus 1 is less or equal to x, which is less or equal to plus 1. And similarly, minus 1 is less or equal to y, and this is less or equal to plus 1. This means x is in fact cos theta, so minus 1 is less or equal to cos theta, and cos theta is less or equal to plus 1. And similarly, this is minus 1 less or equal to sine theta, and this is less or equal to plus 1. This means that domain of the function, domain is of sine theta is equal to R, entire set of real numbers, and the range is range of sine theta is equal to minus 1 to plus 1 inclusive. That's how this is represented by closed interval. Or equivalently, it can also be represented as minus 1 less or equal to sine theta, and this is less or equal to plus 1. Anyway, this is the range for sine theta, and similarly we can define domain for cos theta is equal to R, and range is equal to -1 to +1. And if we ask example, what is domain and range of x equal to 2 cos theta, then here, because 2 is the number that will be multiplied with every possible value of cos theta, therefore domain will still be the same. Domain will be equal to R, but range will be like 2 multiplying with that interval -1 to +1, and this will give you the interval for range equal to -2 to +2. So whatever is the vertical stretch or the number multiplying outside, that will multiply with every possible value of the sine theta or cos theta, and that will give us the range. Now we want to define another function. Now we define another function, which is tan theta in terms of x and y, which is equal to y over x. Now we define another function tan theta, which is basically derived from the same coordinates xy on the unit circle, like this. And for this, obviously, if x becomes equal to 0, the tan theta will become infinity. Obviously, the denominator x cannot be equal to 0, and because when x is equal to 0, tan theta becomes infinite, because at x equal to 0, tan theta approaches to infinity, plus minus infinity. So we have to subtract those values of x from the domain for which tan does not give a real number. Therefore, x cannot have values which are multiples of plus minus pi by 2, or rather odd multiple, which are odd multiple. Because at odd multiples of pi by 2 for values of x, the tan theta will becomes infinite. Thus, the domain will be equal to domain of tan theta will become equal to entire set of real numbers minus those values of x minus x, where x is equal to 2n plus 1 pi by 2 for n belonging to z. So this is what we are not allowed to have for values of x. That's why this is the domain, and range of tan theta will be equal to minus infinity to plus infinity, because its values can be anything between minus infinity and plus infinity. And if we define the domain and range for the other counterpart, which is called cotangent theta, similarly for cotangent theta, which is equal to x over y, because it's simply reciprocal of tan theta. Now cot theta cannot have value the value of y which gives cot theta equal to infinity. That is not possible. So we will exclude those values of y for which cotangent theta tends to infinity. It means y is equal to 0. So we are going to exclude y is equal to 0. And where is y is equal to 0? We'll exclude those values of y for which cotangent, which obviously is y is equal to 0. So what are those values of theta for which y is equal to 0? Those values will be excluded from the domain. Thus, domain will be equal to r minus x, for which x is equal to n pi, because y will be equal to 0 for multiples of pi, for where n belongs to z. So this is we are going to take out from the domain for cotangent theta, and the range, as usual, range of cotangent theta will be equal to minus infinity to plus infinity. Domain and range for secant theta. Okay. Now since secant theta is reciprocal of cos, so this will be 1 over x. Obviously, from the domain we have to exclude those values of theta for which x is equal to 0. So we will exclude those values of theta for which x is equal to 0. And when is x equal to 0? X is equal to 0 when it is y-axis, means theta is odd multiple of pi by 2, means theta is equal to 2n plus 1 pi by 2 for n is belonging to z. Thus domain of secant theta is equal to r minus those values of x for which x is equal to 2n plus 1 pi by 2 where n belongs to z. And similarly, now if we want to range, and because if you take a look on the definition of secant theta, the values of x are always going to be within -1 to +1. It means that the range will have, so range of secant theta will be equal to y, which are greater than or equal to 1, and or when y is less than or equal to -1, or y is less than or equal to -1. So this is how the range of secant theta is defined. And now at the end, now for domain and range. Domain and range of cosecant theta. Cosecant theta which is equal to 1 over y. Here we have to eliminate those values of theta for which y is equal to 0 from the domain, from the real numbers, or we will exclude those values of theta, for which y is equal to 0. And when is y is equal to 0? Y is equal to 0 on entire x-axis. Means n is equal to theta is equal to n pi. Means theta is equal to n pi for n belonging to z. Therefore, thus domain is equal to r minus those values of x for which x is equal to n pi, where n belongs to z, and range is y greater than or equal to 1 or y less than or equal to -1, for the same reason as we defined for secant theta.